So you want to create a clean work area with plenty of room and light. That's very important. They have little LED lights now, it's not too bad. And we talked about the little magnetic screwdrivers or little magnets, little pin magnets that spread out, and you can fetch screws out of the circuitry down there. We talked about touch the case before you reach your hand in there to do anything. You want to gather all the necessary tools for the job, implement a proper safety, all proper safety procedures, and of course turn off the computer. And part of that is unplugging it. But what's the danger with unplugging it before we reach down into a circuit board? So if you have a screw that's shoved down in there and you're going to drop a magnet down in there, you probably want to unplug it, right? But if you're going to be reseating a card, you remember we want to touch the case and then grab the card, because we don't want to just grab the card. We could shock it. An electrostatic discharge can happen, right? So it needs to remain plugged in for that to be safe. Or you could use a grounding strap where you connect a alligator clip to the case somewhere, and then that goes off into the ground outlet or to a strap on a water heater or a copper pipe, something like that. The other end of that wire is wrapped to that because that's grounded. So there's the ground and then there's the neutral in your home. They're not the same thing. So don't stick a ground strap inside of an outlet in the little round hole versus the vertical holes. Don't do that. So that's a neutral, it's not a ground. We have 4 wires in our homes today. Some have 5. Clean work area. So if you have a glass table or a wooden table to keep from scratching it, these computers have sharp corners. You can get a screw trapped between the motherboard or the case, and you're rolling it around. So what you want to do is just, if you don't have anything better, just put some cardboard down on your work surface to protect the computer, not necessarily your stuff, maybe your stuff too, but maybe you're already working on a wooden table, right? But it can still scratch the customer's case or the case that you're working on, whether it's yours or customers or whatever. So a good cheap solution is cardboard. Just use cardboard. It works very well. And then procedure for disassembling continued. We want to disconnect the power cables. We discussed that. You want to wear the anti-static wrist grounding strap. Recall that if it's not plugged in, that is no good. The electricity has to have somewhere to flow. So let's talk about that for a second so you can get some background. So we have something, electricity has some weird phenomena, right? So probably all heard about that. So how do you prevent like lightning? Okay, it's the same exact thing that we're talking about. Basically a static discharge is a little mini lightning bolt. It's the same exact principle. So how do you prevent lightning? So they have ions in the air. In the case where we're touching the case, we're having direct contact because the voltage potential from our finger that can jump, say it's 1.5 volts, it's not enough to bridge the gap to the card itself. But sometimes when you get close, it'll jump because the potential here is enough to reach. So that's why that happens. But when you touch it, you can also discharge it and you may not hear the crack, right? The crack of the arc. The arc is the crack that you hear. When you get close enough, now it has enough potential to jump across that air gap. So the way lightning works is they have ions in the air and the bolt will jump from ion to ion to ion. That's how it conducts to the ground, right? And the way that works is it actually comes from the ground up and then the pulse comes down. So if you look at really high-speed lightning photos, it actually goes up and then you see a big bolt come down as well. So this potential energy is stored in the cloud, that's the positive, and it's trying to reach the ground because it's going to dissipate into the ground, the lower potential. And the way that we stop lightning with a lightning rod, the lightning rod doesn't take the bolt and then reroute it and ground it. It would destroy that wiring. It's not big enough. The way it works is you drain the ions from the air. So that creates a bigger buffer, and hopefully that arc of lightning won't be strong enough to bridge that air gap. With the ions in the air, it actually contaminates the air, and that contaminant is what the lightning uses to conduct. So we have the same thing in the computer. That wrist strap is going to drain the potential energy from you down into the computer before it's ever discharged. So as it starts to build up in your body, so the difference between the lightning and your body is your body isn't walking around charged all the time. you wear a wool coat or something and you rub, and that builds stored energy. And it's just looking for a place to go because it has a potential energy, right? If you think back to physics, the potential energy is what jumps and spans an air gap. So the way this works is, as you build up potential, it's immediately drained down the wrist strap. But it needs a place to go. Where's it going to go? Just to the case is not good enough. You have to have it plugged into the wall. So the case itself, the circuitry in the case may absorb some of it, but normally if you hear an arc, there's a significant voltage potential there. So what you want to do is make sure it's plugged in when you're working on a grounded environment. If you're trying to fish a screw out of there, you might want to unplug it in case you arc something. And again, when you're fishing a screw out, you're going to use a magnetic thing or a long needle nose pliers, and you're not going to have your fingers touching the board, okay?